Alright guys, welcome back. So you've got a belt drive, and again this is a compound belt drive. So B and C are spinning the same RPM and they have the same torque because they're on the same shaft. So your driver is D, and in this case D has a diameter of 8 inches. C has a diameter of 24 inches. B has a diameter of 12 inches. And A has a diameter of 20 inches. And just like gears and sprockets are a ratio of their teeth, and that is because their teeth have to be the same size, which means their circumferences and their diameters fit the same ratios as their teeth. Well, belts and pulleys don't have teeth, so we use ratios of diameters instead, but it comes up to be exactly the same. So what do they tell me about pulley D? Pulley D is hooked to a motor that is spinning 5,000 RPM. And what we need to remember is that speed is an inverse proportion. Okay? They also tell me, well, we'll go from there. So we'll start with that. The speed is an inverse proportion. They tell me that pulley D is spinning 5,000 RPMs, and they want me to find the rotational speed, the RPMs, for pulley A. So here we go. We're going to set up an inverse proportion. Now remember, to set up an inverse proportion, we're going to say D over C is equal to C over D. So a direct proportion would be D over C equals D over C. We're going to flip that side. When we do that, we're going to take our diameters, 8 over 24, equal to, let's keep this up so you guys can actually see. And so diameter of D over diameter of C equals the speed of C, which I don't know, and the speed of D, which is 5,000 RPMs. Now I'm going to cross multiply. When I do that, I get 24C is equal to 40,000. And if I divide both sides by 24, scooch up just a little more here, divide both sides by 24, I get that C is spinning 1,666.7 RPM. Now, because that is on the same shaft as B, that means B is also spinning that speed. So then I come over here and say, okay, now I got a belt between B and A, also in inverse proportion. So I'm going to say B over A is equal to A over B. So B is going to be 12 over 20. So the ratios of their diameters equal to the ratios of their speed. Well, I know the speed of B is 1,666.7 RPM, and I don't know the speed A is spinning, so I'll write it like that. Cross multiply, I get 20A is equal to, and if I multiply that times that, and I haven't rounded, I actually get a nice pretty number. I get 20,000. If I divide both sides by 20, I get 1,000 RPM. Okay. So, in this particular compound belt drive, the original pulley is spinning 5,000 RPMs, and after going through 2 reductions, it is spinning 1,000 RPMs at the output. So that's the way to take an electric motor that spins very quickly and slow down its speed using pulleys, chains, or gears. Okay? So, now we're going to go down a step further here. Okay? Take this same system above, and I want you to note that torque is a direct proportion. Torque is the amount of work this system can do. Okay? And so in this particular scenario, here's what we're going to say. We're going to say that this pulley here has a torque of 50 foot-pounds. Okay? And that's going to be the motor that's attached to it. And we're going to find out what that torque goes to for gear C, because gear C and pulley B and pulley C are on the same shaft. That torque and that torque will be equal, and then this torque will again change from here to here. So same measurement, same everything. So this is a direct proportion. Okay? It is a direct proportion. Now what a direct proportion means is you're going to say D over C equals D over C. Okay? Direct proportions, we don't flip them. We keep them like this. And so the direct proportion is going to be 8-inch diameter over a 24-inch diameter, which is the same thing we started with our speed calculation, 8 over 20. So we said D over C equals C over D, 8 over 24. Here, we're going to say D over C, 8 over 24, but we're going to flip these. This will be D on top, C on bottom. And so the torque for pulley D is 50, and the torque for pulley C is unknown. Okay, it's unknown, so we're going to leave that as C. We're going to cross multiply. I get 8C equals, what do I get here? 8C equals 1200. And if I divide by 8, C equals 150 foot-pounds. So the torque on pulley C is 150 foot-pounds. Now, what I'm going to do is I'm going to say, look, the torque on pulley C has to be the same as pulley B because they're on the same shaft. So that's going to be equal to the torque on pulley B. So now, to go from B to A, we're going to say B over A equals B over A. And I'm going to do my diameters. So in this case, it's going to be 12 over 20, same as we did for the speed calculation. But instead of A over B, it's going to be B over A because this is a direct proportion. Well, I know the torque for B is 150. So, helps if I write the right number, 12 over 20. So, the torque for B is 150, and the torque for A is unknown. And we're going to cross multiply, and I get 12A is equal to 3,000. And if I divide by 12, that's going to give me A equals 250 foot-pounds. So what happens here, folks, just pay attention to what happens. The speed goes from 5,000 to 1,000. It's divided by 5. The amount of work that this system can do, the torque goes from 50 to 250. It is multiplied by 5. You don't get anything for free in these systems, and so you have to give up speed to be able to do more work. All right? So let's go to the next page here. So I've got a gear drive. This is another compound gear drive question. Okay, compound gear drive question here. And they give me some scenarios. They say that A has 12 teeth. And they tell me that A is 5,000 RPM. 5,000 RPM. And they tell me that it has a torque of 40 foot-pounds. 40 foot-pounds. And this is my driver. This is my driving gear. Okay? So then they give me the information for gear B, gear C, and gear D. Gear B has 36 teeth. Gear C has 12, and gear D has 48. We expect our speed to go down. We expect our torque to go up, and they want us to calculate both. So let's do speed first. I'm going to do speed here. So here's speed. I'll remind you, speed is an inverse proportion. Inverse proportion. So that means on the left-hand side, if you put A over B, the right-hand side has to be B over A. So I am going to say, for speed, I'm going to go A over B. I'm going to go 12 over 36 for the gear teeth. So A over B. And on this side, I have to go B over A. Well, I don't know B, and I know A is 5,000 RPM. I'm going to cross multiply that, and I get 36B is equal to 60,000, which gives me B equal to 1666.7 RPM. And since B and C are on the same shaft, if this is spinning 1666 RPM, this is spinning 1666 RPM. So what that means is that's also equal to C. Okay, so that's how fast C is spinning. Now I'm going to set up another inverse proportion. I'm going to say C over D. C over D equals, and remember, If I do C over D and it's an inverse proportion, this side has to be D over C. 1666.7. We're going to cross multiply this. We'll get 48D is equal to 20,000. And if we divide by 48, that's going to give me D equals 416.7. 416.7 RPM. Okay, 416.7 RPM. So that is how we find our speed. If we do our torque, torque is a direct proportion. So let's go back and do it again. We're going to go A over B, but this time we're going to say A over B equals A over B, which will be 40 over B, right? Because they told me the torque was 40 foot-pounds, okay? So now, given that, we're going to cross multiply, and we get 12B equals 1440. And if we divide that by 12, we get B equals 120 foot-pounds, which is also equal to C, because again, they're on the same shaft. They have to have the same torque. So then we come over here and we say C over D equals C over D. C over D equals C over D because it's a direct proportion. Cross multiply, you get 12D equals 5760. Divide that by 12, and you get 480 foot-pounds of torque. So gear D is delivering 480 foot-pounds of torque from a 40 foot-pound of torque motor. Okay. This is how a lot of tractors and ground engaging implements work, is that the motor spins at one speed, and the gear ratio between that and the final rear wheel puts out a ton of torque. Okay, it's also how low gears and tractor trailers work. Okay, so anyway, speed and torque, one is an inverse proportion, one is a direct proportion. One more, same question but with pulleys. So we're going to do this exact same question again but with pulleys. Okay, so here we go. I am given that pulley A has a diameter of 5 inches. And it is attached to a motor that puts out 30 foot-pounds of torque and is spinning 8,000 RPMs, which is pretty typical of an electric motor. Some of them spin even faster. So we've been given all this spec. This comes right off the motor of pulley A. And then all we know about pulley B is it has an 18-inch diameter. Pulley C has a 4-inch diameter, and pulley D has a 24-inch diameter. Okay, boom, 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 boom. And they want us to find the speed, and they want us to find the torque. So, if I slide my paper up here, got all the info I need here in my picture. We're going to put the speed over here on the left. We're going to put the torque over here on the right. So we're going to go speed over here. Remember, speed is an inverse proportion. So whatever you do on top, your ratio top to bottom, you're going to flip it on the right-hand side. So here goes. What have we got? We have got, I'm going to start with A here. It's going to be 5 inches over 18 inches. So I did A over B, and that has to equal B over A. So we get 18B equals a pretty big number, 40,000. And if you divide that by 18, you're going to get B is 2,222.2 RPM. Now the magic, because this is clustered the way it is this pulley here and this pulley here on the same shaft. That means that this one's spinning 2,000 RPMs, this one's spinning 2,000 RPMs. So that's also equal to C. So now I do this belt here, and what am I going to do? I'm going to go C over D equals, and since it's inverse, C over D equals D over C. And if I multiply that, I get 24D equals 88.8. And when I divide by 24, I'm going to get 370.4 RPMs. So this thing's spinning 8,000 RPMs, and all the way over here, this guy's only spinning 370. Huge difference. Now, because of that difference in speed, we're going to get a huge difference in torque, okay, or the work that this system can do. So torque is a direct proportion. Okay? Torque is a direct proportion. So here goes. This time I'm going to say A over B equals A over B. So in this case, it's going to be 30 over B. My unknown will be on bottom this time. So A over B equals B over A. A over B equals A over B. Cross multiply, I get 5B is equal to 540, which is 18 times 30. Divide by 5, and I get 108. Excuse me, 108, which is also equal to C, and that's in foot-pounds if you're interested in units. Okay, so that's C. So then I come over here, why is this equal to this? Because they're on the same shaft. Whatever this one's doing, this one's also doing. So now let's go. We're going to say C over D equals C over D. So we multiply, cross multiply, we get 4D equals 2,592. That's 108 times 24. And then we divide by 4, and we get D equals 648 foot-pounds. Okay, so that is what you can accomplish with belt drives, gear drives, and chain drives. You can slow them down, you can speed them up, you can increase the torque, you can decrease the torque. It's very, very useful because you can use one size motor to get basically any speed or any torque you want based on your gears, your chains, or your pulleys. So anyway, that is an application of direct and indirect proportions, and I hope that helps you. Make sure you get your homework done, guys, and I appreciate you watching.